In order to add or subtract fractions, even as simple as this problem, we have to have a common denominator. So there's more than one way to do this problem. In fact, there's multiple ways we could achieve this answer. You will not get to use a calculator. So that's why there's no calculators out there in desks. What we're going to do is I'm going to make up here, and I'm going to show you a couple different ways of doing this. The first way is the butterfly method. I take whatever the symbol is, I put it in between, and then I cross it out. I'm going to multiply these. 3 times 5 is 15. Yes, you always have to start with this diagonal first, always. Then I take the next diagonal. 1 times 8 is 8. And on the bottom, I multiply the denominators to end up with 40. If I take 8 away from 15, I get 7 over 40, and that's my final answer. Now, is there a different ways we could do this? Yes, there's different ways we could do this. You may have initially learned this back in middle school or even elementary school, is finding a common denominator. So I'm going to take it times 8, times 5, times 5, and you're going to see we achieve the exact same thing. We get 15 over 40 minus 8 over 40, and when the denominators are the same, we keep the denominators the same. 15 subtract 8 is 4. Or sorry, 15 subtract 8 is 7. So whether you use the butterfly method or you use this idea of finding a common denominator, we achieve the exact same answer. So we know there's more than one way to do this. I'm going to go ahead and I'm going to use the butterfly method. This symbol goes in between. And first I'm going to start by multiplying. So I'm going to take 4 times 3 to get 12, 1 times 11 to get 11, and when I multiply I get 33. 12 subtract 11 is 1, and I end up with 1 over. Second type of problem. We are going to go with 13 over 2x plus 3 over 5. Again, we have more than one way we can achieve this, and I'm going to demonstrate both ways. You will not have to demonstrate both ways. I just want to show you both. So I personally like to use the butterfly method. I take the symbol, I put it in between. I always have to start with this diagonal first. So I'm taking 5 times 13, and I end up with, I'm going to come off to the side, 5 times 13 is 65. And then I'm going to take 3 times 2x to get 6x, and then I multiply the bottoms to end up with 10x. This cannot be broken down any further. That is my final answer. Now, is there an alternative to doing this? Yes. If you wanted, you could do something like this. You could look at this and go, okay, I prefer the common denominator route. And I recognize that 10x would be my common denominator, my least common denominator. So I'm going to take this times 2x, you're welcome just to watch, times 5, and I end up with the same thing. I end up with 65 over 10x, subtract 6x over 10x, and when I subtract 65, subtract 6x, oh, so sorry, this should have been subtraction over here. Am I right? Was this subtraction here or addition? I'm sorry. This was addition. Oh, so this should have been addition too. Okay. So here's 65 plus 6x on top and a 10x on the bottom. Either way, you can get the right answer. It's what makes most sense to you. And honestly, which way can you do the fastest? Okay, within your groups. Here we go, within your groups. Okay, so for this problem, I'm going to choose to do the butterfly method, but this is where I think kids are going to get confused. This negative sign, I'm going to cross it out and bring it up top. So if it's in front, it gets crossed out, it's brought up top. So I'm going to do butterfly, the symbol in between is addition, and I'm going to first multiply these two. So I have 7 times negative 11, which is negative 77, and 1 times 3x, which is 3x. Multiply the bottoms, you get 21x. I do need to ask myself, I know that 3 and 21 are both divisible by 3. Is 77 divisible by 3? And I'm going to check upside. I'm hearing no, which is good to hear. It is not. This is my final answer. So this is the third type of problem we've gone over today. And in this problem, I want you to recognize that we can factor x squared minus 9. It factors into x plus 3 and x minus 3. And we've previously have gone over how that occurs. So now I'm going to look at the denominators. I know x squared minus 9. When we say it factors, we know that we're just rewriting it in an equivalent manner. So they both contain an x plus 3, but the right-hand side is missing an x minus 3. Now the denominators are the same. But what if you attach something new to a denominator, you must also attach it to a numerator. so that we do not impact the value of this original fraction. Okay, now I have the exact same denominators, so I can write down x plus 3. I'll move this down so everybody can see, and x minus 3. And then I'm going to make two parentheses. In between them will be addition. There's a single lonely 5 on the left-hand side. And on the right-hand side, I'm going to do a little bit of work here. I'm going to first distribute the 2 to get 2x, and distribute the 2 again to get a negative 6. When I combine like terms, I have 5 plus 2x minus 6. Combining like terms, I end up with 2x over x plus 3 and x minus 3. So I'm going to start on this. This factors into x plus 2 and x minus 2. So this is equivalent to this. And my right-hand side, this is simply missing an x plus 2. Whatever I attach on the bottom, I must also attach on top in the numerator position. Now they both contain an x plus 2 and x minus 2. I have 7 on the left, a plus sign in between. On the right, I have 1x plus 2. So when I combine like terms, I get 1x plus 9 over x plus 2 and x minus 2. It's not necessary that you have a 1 in front of the x, but x plus 9 would be in the numerator, and x plus 2 and x minus 2. Please do not FOIL, do not distribute these, leave them in this current form. Okay, put the cups side by side if they're not already in that form. I'm going to try to trick you with this one. Ready, get set, and go. There, kiddos. I'm going to start by taking this negative sign, and I'm going to move it up with the 5. And then before I even start to do this, I recognize that I can factor. X squared minus 9 factors into x plus 3 and x minus 3. I already have an x minus 3, so I'm going to attach an x plus 3 to the right-hand side. All right, now, this symbol goes right here, so I've already used it. I'm going to take negative 5 times, oh my goodness, I'm so sorry here. I'm so sorry. I just broke out and I was going to do the butterfly method. I'm so sorry. That just threw you off, didn't it? I have negative 5 on the left-hand side. I brought down the subtraction sign, and now I'm going to take 3 times x to get 3x, and 3 times 9 to get a positive 9. On the bottom is x plus 3 and x minus 3. Now, here's where I did see some students when I was walking around. One is some students forgot to take the 3 and to distribute it to the 3. The next thing is students forgot to distribute this subtraction sign to both quantities. So I have negative 5, subtract 3x, subtract 9. That's the numerator. So when I combine, I have negative 3, x minus 14 over x plus 3 and x minus 3. Okay, here we go. So I recognize this factors into x plus 1, x minus 1. And I'm missing an x minus 1, so I attach it at the top and the bottom. And now, this time, I'm not going to make that mistake. I went back into doing the butterfly method. I dropped down the lonely 7, and then I have 2x minus 2. And when I combine like terms, I end up with 2x plus 5 over x plus 1 and x minus 1. When I look at this problem, I want you to recognize that x is all by itself. It's a lonely x, and this x has a subtract 4 with it. When I find a common denominator, I cannot do subtract 4. I cannot do that. It has to be attached by multiplying. So a common denominator here, and we could use the butterfly method, but a common denominator would be attach an x to the right side, both top and bottom, and subtract an x subtract 4 to the left and to the top and bottom of the left-hand side. Now we have a common denominator. They both contain a single x, and they contain an x minus 4. I have two parts, the right and the left, separated by addition sign. Now on the left-hand side in the numerator, I'm going to go ahead and I'm going to FOIL this. Front, outside, inside, last. Front, outside, inside, last. And when I combine, I get x squared, subtract 2x, subtract 8. Now when I combine like terms in the numerator, I have x squared plus, well, negative 2x and positive 3x is a positive 1x minus 8. That is not factorable. This is my final answer. This is simplified. It is my final answer. In this problem, you could do the butterfly method. You absolutely could. Or you could do butterfly, or we could find common denominator. It is your choice. Does anybody want me to demonstrate the butterfly method for this problem? Okay, let's do it. So I'm going to first multiply these two. So x minus 1 times x plus 3. I did this diagonal. Then it's going to be separated by addition. And then I'm going to multiply this, 2 times x. And then I'm going to multiply the bottoms. And then I'm going to go ahead and I'm going to FOIL. So I'm going to do front, inside, or front, inside, outside, and last. This is all the numerator. And when I combine like terms, I have x squared. I'm going to circle all the terms that have an x, just a single x. Negative 1 plus 3 would be a positive 2, and positive 2 and positive 2 is a positive 4. So this is what I have so far in the numerator. But then I have to ask myself, can I factor this trinomial? Is it factorable? Do I know two numbers that multiplied to give me negative 3 and combined to give me a positive 4?
Yeah.
This tells me they'd have to be different signs. So one is positive and one is negative. And whether I use a positive 3 and a negative 1 or a positive 1 and a negative 3, they don't combine to give you a 4. This is my final answer. This is our last type. We have two problems like this on our quiz. I'm going to start by seeing, can I factor the denominator? What multiplies to equal negative 6 and combines to equal negative 5? The negative 6 tells me they're different signs. The negative 5 tells me the larger of the two numbers, if we can factor it, is negative. Negative 6, positive 1. Multiply and combine. So it's easy because our leading coefficient is a 1. Bless you. X minus 6, x plus 1. Okay, got that. Hey, I already have an x minus 6 here. Wonderful. What do I need to attach to the right-hand side so the denominators will be the same? X plus 1 on the bottom, x plus 1 on top. Okay, I have two different tops. The numerator on the left, the numerator on the right, and they're separated by subtraction. 5x is all by itself on the left-hand side. And on the right-hand side, I have an x squared plus x. I'm going to distribute this negative sign, and I have 5x minus x squared minus x. This is just the numerator after I distribute. I end up with negative x squared plus 4x. Now, at this point, I would accept this, but I want you to recognize that both of these terms have an x, so we could factor out an x to get negative x plus 4. This would also suffice as a correct answer, either one of these options. What multiplies to equal 6 combines to give you 5? So it's going to be 3 and 2 multiplies and combines. So x plus 3, x plus 2. 3 over x plus 3, x plus 2, plus 4 over x plus 2. Okay, I'm looking for a common denominator. My common denominator, I need to attach an x plus 3. Now, I have a common denominator. I'm going to write that down as x plus 3 and x plus 2. And I have two parts on top. I have the 3 and the 4x plus 12. Now, when I combine everything, I'm going to come back over here. I have 1 4x. So I have a 4x, and 3 plus 12 is 15. And that's my final answer.